Cable entry options for National Electrical Code projects involving non-metallic tray cable. Firstly, it involves non-metallic cable fittings. These fittings provide a seal between the cable and the enclosure while maintaining the integrity of the enclosure's National Electrical Manufacturers Association rating. Look for products that are National Electrical Manufacturers Association 4X rated and have lock nuts for secure attachment. Examples include Cooper-Krauss-Heinz CGB series in aluminum or steel and Appleton ATC series in aluminum or steel. Secondly, you can consider liquid-tight conduit. Install the tray cable into liquid-tight conduit and terminate the conduit with a suitable liquid-tight connector. Ensure that the connector meets the National Electrical Manufacturers Association rating requirements and provides a secure seal. When dealing with non-metallic MV-90 cable, consider these options. Firstly, use insulating bushings. These bushings provide insulation and support for the cable while passing it through the enclosure. However, they do not typically provide a seal. It is recommended to use them in conjunction with an additional sealing method. These methods include firstly, silicone sealant. Apply a bead of silicone sealant around the bushing and cable to create a weatherproof seal. Secondly, use butyl rubber gaskets. Use gaskets specifically designed for the bushing and cable size to create a watertight seal. Secondly, you can use non-metallic cable fittings for high-voltage cables. Some manufacturers offer non-metallic cable fittings specifically designed for high-voltage cables. These fittings provide a seal and meet National Electrical Manufacturers Association rating requirements. Examples include Thomas & Betts T and B4000, 100/4000, 140 series and Raycom UMV series. There are some general considerations to keep in mind. Ensure that the chosen cable entry method meets the National Electrical Manufacturers Association rating requirements for the enclosure's intended location. Use lock nuts or other secure attachment methods to prevent cables from being pulled out of the enclosure. Choose methods that provide adequate ingress protection for the enclosure and cables. It is critical to follow the manufacturer's installation instructions carefully to ensure proper sealing and protection. For non-metallic tray cable, using non-metallic cable fittings provides a reliable seal and maintains the enclosure's National Electrical Manufacturers Association rating. Ensure the fittings are National Electrical Manufacturers Association 4AX rated and equipped with lock nuts for secure attachment. Consider aluminum or steel options from Cooper-Krauss-Heinz CGB series or Appleton ATC series. Alternatively, utilize liquid-tight conduit by installing the tray cable within it and terminating with a suitable liquid-tight connector. Verify that the connector adheres to National Electrical Manufacturers Association rating requirements and provides a secure seal. For non-metallic MV-90 cable, begin with insulating bushings to provide insulation and support as the cable passes through the enclosure. Since these bushings typically don't offer a seal, supplement them with additional sealing methods. Apply a bead of silicone sealant around the bushing and cable to establish a weatherproof barrier. Alternatively, employ butyl rubber gaskets specifically designed for the bushing and cable size to achieve a watertight seal. Explore non-metallic cable fittings designed for high-voltage cables offered by some manufacturers. These fittings ensure a seal and meet National Electrical Manufacturers Association rating requirements. Consider options like Thomas & Betts T and B4000, 100/4000, 140 series or Raycom UMV series. When selecting cable entry methods, prioritize adherence to National Electrical Manufacturers Association rating requirements pertinent to the enclosure's location. Implement lock nuts or alternative secure attachment methods to safeguard against cable displacement from the enclosure. Opt for methods that deliver sufficient ingress protection for both the enclosure and cables. Always adhere meticulously to the manufacturer's installation instructions to guarantee correct sealing and protection. The National Electrical Code provides guidelines for safe electrical installations. Understanding these guidelines, especially regarding cable entries into enclosures like switchgear and transformers, is crucial for ensuring safety and compliance. When dealing with non-metallic tray cables, several options exist for creating a secure and compliant cable entry. Non-metallic cable fittings offer a reliable solution. These fittings are designed to seal the cable entry point, maintaining the enclosure's National Electrical Manufacturers Association rating. Look for fittings that are National Electrical Manufacturers Association 4X rated, indicating their suitability for outdoor use and resistance to corrosion. Additionally, ensure the fittings have lock nuts to securely attach them to the enclosure. Cooper Crouse-Hinds CGB series and Appleton ATC series are examples of non-metallic cable fittings available in aluminum or steel. Another option involves using liquid-tight conduit. By encasing the tray cable within liquid-tight conduit and terminating it with a suitable liquid-tight connector, a secure and sealed entry is achieved. The connector must meet the National Electrical Manufacturers Association rating requirements for the application. Moving on to non-metallic MV-90 cables, different strategies are needed to ensure a proper cable entry. Insulating bushings provide a basic level of insulation and support as the cable passes through the enclosure wall. However, they do not typically create a watertight seal on their own. Therefore, they should be used in conjunction with other sealing methods. Applying silicone sealant around the bushing and cable creates a weatherproof barrier. Alternatively, use butyl rubber gaskets specifically designed for the bushing and cable size to form a watertight seal. For high-voltage applications involving MV-90 cables, consider using non-metallic cable fittings specifically designed for these cables. These fittings offer both a secure seal and compliance with National Electrical Manufacturers Association rating requirements. Examples include the Thomas & Betts TA&B 4100/4140 series and the Raycom UMV series. Regardless of the chosen method, several general considerations are essential. Always ensure that the cable entry method meets the National Electrical Manufacturers Association rating requirements for the enclosure's intended environment. Use lock nut or other secure attachment methods to prevent cables from being pulled out of the enclosure, compromising the seal and potentially creating a safety hazard. Select methods that provide adequate ingress protection, preventing water, dust, and other contaminants from entering the enclosure. Following the manufacturer's installation instructions meticulously is crucial for ensuring proper sealing and protection. Neglecting this step can lead to premature failure of the cable entry and potential safety risks. In summary, selecting the appropriate cable entry method for switchgear and transformers in National Electrical Code projects requires careful consideration of the cable type, environmental conditions, and safety requirements. Non-metallic cable fittings, liquid-tight conduit, insulating bushings with sealant or gaskets, and specialized high-voltage cable fittings are all viable options, depending on the specific application. Paying attention to National Electrical Manufacturers Association ratings, secure attachment, ingress protection, and proper installation is essential for ensuring a safe and reliable electrical installation. To elaborate further, the selection of appropriate cable entry methods for switchgear and transformers within National Electrical Code compliant projects necessitates a comprehensive understanding of various factors. These factors encompass the type of cable employed, the prevailing environmental conditions, and the stringency of safety regulations mandated for the installation. For projects utilizing non-metallic tray cable, the utilization of non-metallic cable fittings emerges as a pragmatic solution. These fittings are meticulously engineered to establish a robust seal between the cable and the enclosure, thereby upholding the enclosure's designated National Electrical Manufacturers Association rating. It is imperative to procure fittings that bear a National Electrical Manufacturers Association 4X rating, signifying their resilience to outdoor exposure and resistance to corrosive elements. Moreover, the inclusion of lockers is crucial for ensuring the secure fixation of the fitting to the enclosure. Prominent examples of non-metallic cable fittings encompass the Cooper Crouse-Hinds CGB series, available in both aluminum and steel variants, as well as the Appleton ATC series, offering similar material options. Conversely, projects incorporating non-metallic MV-90 cables necessitate a distinct approach to guarantee efficacious cable entry. While insulating bushings proffer a foundational layer of insulation and support as the cable traverses the enclosure, they typically fall short of providing a hermetic seal. Consequently, it becomes imperative to augment their functionality with supplementary sealing methodologies. The application of silicone sealant around the bushing and cable serves as an effective means of establishing a weatherproof barrier, safeguarding against the ingress of moisture and environmental contaminants. Alternatively, the implementation of butyl rubber gaskets meticulously tailored to match the dimensions of the bushing and cable offers a watertight seal, further enhancing the protection against water intrusion. For applications entailing high-voltage MV-90 cables, it is judicious to contemplate the utilization of specialized non-metallic cable fittings meticulously crafted to accommodate such high-voltage applications. These fittings not only furnish a secure seal but also conform to the stringent National Electrical Manufacturers Association rating prerequisites, thereby ensuring compliance and safety. Notable examples of such fittings include the Thomas & Betts TMB 4000, 100/4000, 140 series and the Raycom UMV series, both of which epitomize industry standards for performance and reliability. Irrespective of the specific methodology adopted, several overarching considerations warrant meticulous attention throughout the installation process. It is paramount to ascertain that the chosen cable entry method aligns seamlessly with the National Electrical Manufacturers Association rating stipulations governing the enclosure's operational environment. The integration of lock nuts or alternative secure attachment mechanisms is indispensable for preventing the inadvertent detachment of cables from the enclosure, thereby mitigating the risk of compromising the integrity of the seal and potentially precipitating safety hazards. Furthermore, the selection of methods that afford adequate ingress protection is of paramount importance, ensuring that the enclosure and its internal components remain shielded from the detrimental effects of water, dust, and other pervasive contaminants. Moreover, adherence to the manufacturer's installation directives is non-negotiable, as meticulous compliance with these guidelines is pivotal for ensuring the proper sealing and protection afforded by the cable entry system. Deviation from these instructions may engender premature system failure and elevate the potential for safety-related incidents. In summation, the judicious selection of cable entry methods for switchgear and transformers within National Electrical Code compliant projects necessitates a multifaceted evaluation encompassing cable type, environmental dynamics, and stringent safety mandates. Non-metallic cable fittings, liquidtight conduit, insulating bushings augmented with sealant or gaskets, and specialized high-voltage cable fittings each present viable options contingent upon the distinct requirements of the application. Prioritizing National Electrical Manufacturers Association ratings, secure attachment protocols, ingress protection measures, and meticulous installation practices is quintessential for fostering a safe, dependable, and code-compliant electrical installation. The meticulous selection of cable entry methods for switchgear and transformers within National Electrical Code compliant projects mandates a comprehensive assessment of myriad variables. These variables encompass the specific type of cable employed, the environmental milieu in which the equipment operates, and the stringent safety protocols mandated by regulatory bodies. For installations utilizing non-metallic tray cable, the implementation of non-metallic cable fittings represents a judicious choice. These fittings are meticulously engineered to establish a robust seal between the cable and the enclosure, thereby upholding the enclosure's designated National Electrical Manufacturers Association rating. It is imperative to procure fittings that bear a National Electrical Manufacturers Association 4X rating, indicative of their suitability for deployment in outdoor settings and their inherent resistance to corrosive agents. Furthermore, the incorporation of lock nuts is indispensable for ensuring the secure and steadfast fixation of the fitting to the enclosure. Prominent exemplars of non-metallic cable fittings encompass the Cooper-Krauss-Heinz CGB series, available in both aluminum and steel variants, as well as the Appleton ATC series, offering analogous material alternatives. Conversely, projects incorporating non-metallic MV-90 cables necessitate a differentiated strategy to ensure efficacious cable entry. While insulating bushings afford a foundational layer of insulation and support as the cable traverses the enclosure, they typically lack the capacity to furnish a hermetic seal. Consequently, it becomes imperative to augment their functionality with supplementary sealing methodologies. The application of silicone sealant around the bushing and cable constitutes an effective means of establishing a weatherproof barrier, thereby precluding the ingress of moisture and environmental contaminants. Alternatively, the utilization of butyl rubber gaskets, meticulously tailored to conform to the dimensional specifications of the bushing and cable, provides a watertight seal, further bolstering the protection against water intrusion. For applications entailing high-voltage MV-90 cables, it is judicious to contemplate the deployment of specialized non-metallic cable fittings meticulously designed to accommodate such high-voltage application. These fittings not only furnish a secure seal, but also adhere to the stringent National Electrical Manufacturers Association rating prerequisites, thereby ensuring compliance and safety. Noteworthy instances of such fittings include the Thomas & Betts T&B 4000, 100/4000, 140 series and the Raycom UMV series, both of which epitomize industry standards for performance and reliability. Irrespective of the precise methodology employed, several overarching considerations warrant scrupulous attention throughout the installation process. It is of paramount importance to ascertain that the selected cable entry method aligns seamlessly with the National Electrical Manufacturers Association rating stipulations governing the enclosure's operational environment. The integration of lock nuts or alternative secure attachment mechanisms is indispensable for preventing the inadvertent dislodgement of cables from the enclosure, thereby mitigating the risk of compromising the integrity of the seal and potentially precipitating safety hazards. Furthermore, the selection of methods that afford adequate ingress protection is of paramount significance, ensuring that the enclosure and its internal components remain shielded from the deleterious effects of water, dust, and other pervasive contaminants. Moreover, adherence to the manufacturer's installation directives is non-negotiable, as meticulous compliance with these guidelines is pivotal for ensuring the proper sealing and protection afforded by the cable entry system. Deviation from these instructions may engender premature system failure and elevate the potential for safety-related incidents. In summary, the judicious selection of cable entry methods for switchgear and transformers within National Electrical Code compliant projects necessitates a multifaceted evaluation encompassing cable type, environmental dynamics, and stringent safety mandates. Non-metallic cable fittings, liquidtight conduit, insulating bushings augmented with sealant or gaskets, and specialized high-voltage cable fittings each present viable options contingent upon the distinct requirements of the application. Prioritizing National Electrical Manufacturers Association ratings, secure attachment protocols, ingress protection measures, and meticulous installation practices is quintessential for fostering a safe, dependable, and code-compliant electrical installation. To further elaborate on the intricacies of cable entry solutions for National Electrical Code projects, a deeper dive into specific product categories and installation best practices is warranted. When considering non-metallic cable fittings for tray cables, it's essential to understand the nuances of different National Electrical Manufacturers Association ratings. While National Electrical Manufacturers Association 4X is often mentioned, other ratings like National Electrical Manufacturers Association 3R, which provides protection against rain and sleet, might be sufficient depending on the specific environment. Always consult the National Electrical Code and local codes to determine the appropriate rating for the application. Furthermore, the material selection for these fittings should be carefully considered. Aluminum fittings are lightweight and corrosion resistant, making them suitable for many outdoor applications. Steel fittings, while heavier, offer greater strength and durability, particularly in environments where mechanical stress is a concern. When using liquid-tight conduit, ensure that the conduit and connectors are properly sized for the cables being installed. Overfilling the conduit can damage the cables and reduce their lifespan. Additionally, proper grounding and bonding of the conduit system are crucial for safety. For non-metallic MV-90 cables, the choice between silicone sealant and butyl rubber gaskets depends on the specific requirements of the installation. Silicone sealant is generally easier to apply and provides excellent adhesion to a variety of surfaces. However, it may not be as resistant to certain chemicals as butyl rubber. Butyl rubber gaskets offer a more robust seal and are less prone to degradation over time, but they require careful installation to ensure a proper fit. When using non-metallic cable fittings for high-voltage cables, pay close attention to the manufacturer's instructions regarding cable preparation and termination. Improper preparation can lead to premature failure of the fitting and potential safety hazards. In addition to the specific product categories, there are several general installation best practices that should be followed. Always use the correct tools for the job. Using the wrong tools can damage the cables or fittings and compromise the integrity of the installation. Inspect all components before installation to ensure that they are free from defects. Damaged components should be replaced immediately. Tighten all connections to the manufacturer's specified torque. Over-tightening can damage the components, while under-tightening can lead to loose connections and potential safety hazards. Properly support the cables to prevent strain on the cable entries. This is particularly important for long cable runs or in areas where there is vibration. Finally, always document the installation. This includes recording the type of cable, the type of fittings used, and the date of installation. This information will be helpful for future maintenance and troubleshooting. In conclusion, selecting the appropriate cable entry methods for switchgear and transformers in National Electrical Code projects requires careful consideration of a variety of factors. By understanding the nuances of different product categories, following installation best practices, and consulting the National Electrical Code and local codes, you can ensure safe, reliable, and compliant electrical installation. Cable entry methods for switchgear and transformers in National Electrical Code projects require careful selection and installation to ensure safety, reliability, and compliance. For non-metallic tray cables, non-metallic cable fittings are a common choice. Look for fittings that meet National Electrical Manufacturers Association 4X standards for outdoor use and corrosion resistance. Options like Cooper-Crouse-Hinds CGB series and Appleton ATC series are available in aluminum or steel. Alternatively, liquidtight conduit can be used by encasing the cable and terminating with a liquidtight connector, ensuring it meets National Electrical Manufacturers Association rating requirements. For non-metallic MV-90 cables, insulating bushings offer insulation and support but require additional sealing. Silicone sealant can create a weatherproof barrier, while butyl rubber gaskets provide a watertight seal. Specialized non-metallic cable fittings for high-voltage cables, such as Thomas and Betts T and B4000, 100/4000, 140 series and Raycom UMV series, offer secure seals and National Electrical Manufacturers Association compliance. General considerations include ensuring the chosen method meets the appropriate National Electrical Manufacturers Association rating for the environment, using lock nuts for secure cable attachment, and providing adequate ingress protection. Always follow manufacturer's instructions for proper sealing and protection. When selecting non-metallic cable fittings, consider the National Electrical Manufacturers Association ratings such as National Electrical Manufacturers Association 4X for outdoor and corrosive environments, or National Electrical Manufacturers Association 3R for rain and sleet protection. Choose materials like aluminum for corrosion resistance or steel for greater strength in mechanically stressed environments. When using liquidtight conduit, ensure proper sizing to avoid cable damage and maintain grounding and bonding. For non-metallic MV-90 cables, decide between silicone sealant, which is easy to apply but may be less chemically resistant, and butyl rubber gaskets, which offer a more robust seal but require careful installation. High-voltage cable fittings require precise cable preparation and termination. General installation best practices include using correct tools, inspecting components for defects, tightening connections to specified torque, and providing cable support. Document the installation with cable types, fittings, and installation dates for future maintenance. In summary, cable entry methods in National Electrical Code projects demand careful planning, product selection, and installation to ensure safety, compliance, and reliable electrical systems.